Okay. Kita sambung balik ya. Window. Alright, thank you for tadi siapa? Azrin ke? Nasri ke? Yang remind ya. Thank you very much. So kita sambung perspective of class diagram. Kita go back ke lah ya. Alright, class diagram is a structural types of diagram dalam UML diagram type. So it's equivalent dengan ERD. Yeah, usually UML is equivalent with ERD. Cuma beza dia, ERD dia tak capture operation. UML dia capture operation. So that's the difference. So untuk perspective of class diagram ni dia ada dua, which is kita refer dia based on the visual notation yang kita nampak ni ya. Untuk conceptual, basically we can name it as cell, just empat segi cell ni. And then another one is like this, a cell with line tapi kosong dekat sini. Tapi sebenarnya class diagram dia ada tiga bahagian. Yeah. The name of the class, the attribute, and the operation. Okay. This is the specification. Specification ni bila if specification and implementation ni dia jadi lebih detail lah berbanding conceptual. Tapi selalunya if create untuk class diagram kita pakai yang ini. Conceptual tapi kena ada tiga partition ni, yeah? The name, the attribute and the operation. Okay. Tapi you can go detail, even detail for developers, you can use this. This is specification type. Yeah. Yang ini for implementation. Yeah. So dia ada a detail lah value, attribute, parameters yang kita boleh letak dekat sini ya. Alright. Okay, during the formulations of a domain model, for example, you would seldom move past the conceptual perspective. Selalunya kita boleh go straight to specification ataupun the implementation model. Tapi untuk class basics, saya boleh terima sampai ni lah, sampai this one. At least untuk operation ni dia ada positif ataupun negatif. Ini menunjukkan private ataupun public ya. Types of operation yang kamu provide untuk class tersebut. Okay. So analysis models will typically feature a mix of conceptual and specification perspective. Okay. So design model development will typically start with a heavy emphasis on the specification perspective and evolve into implementation perspective. So asas dia datangnya daripada sinilah. Ya, daripada sini dia lagi lebih detail menjadi specification, daripada specification kita detail up untuk implementation. Okay. Sebab dekat sini mungkin ada daripada analyst akan capture sampai sini, tapi programmer akan fill in bahagian yang ini, bahagian detail-detail belakang ya, the parameters. So, mungkin ia ini diisi oleh programmer. So the diagram, a diagram can be interpreted from various perspectives for conceptual, specification ataupun implementation. Okay, conceptual, the meaning of it represent the concept in the domain. Sometimes bila kita cakap dengan user, kita tak pakailah specification type. Kita mungkin pakai simple class, which is the square and just a name of the class. Okay. But then when we talk among analysts, probably we use specification kind of perspective. Ya, tapi antara developers dengan analyst, kita gunakan implementation kind of perspective. So kita ikut kesesuaian lah, ikut kesesuaian ya. Itu dari segi praktis lah. So kita tengoklah what is a class. A class is a blueprint for an object, yang mana they encapsulate operation together with the object. So what is an object? Sebab dalam UML dia melihat an object ada behavior dia. So mungkin dalam kelas OOP sebelum ni kamu pernah dengar lah, an object, they see a things, and each things ada dia punya behavior dia. What does it mean by behavior? Things that they can do. Contohnya, kalau kerusi ada roda, so what kerusi ada roda can do? You can reverse it, you can bring forward it, or you can flip it. So that is the behavior for the kerusi beroda tersebut. Okay, an object belongs to a group or category called class. So dalam satu class, it could be referred as an object or a group of objects. So objects and classes go hand in hand. We can't talk about one without talking about the other. So the entire point of OOD, object-oriented design, is not about objects, but it's about classes, because we use classes to create objects. A class describes what an object will be, but it isn't the object itself. Hopefully you faham sebab dah belajar OP. Each object was built from the same sets of blueprints, and therefore it contains the same component. So it comes from the same container, tapi probably they can have a different type to it, and which have a specific behavior on each of that object types, which belongs to the same class. Begitulah lebih kurangnya. So each object has its own properties and methods, tapi dia mesti share the same common dia ada common similarity. So that's why it belongs to the class. The standard meaning is that an object is an instance of a class. An object is an instance of the class, okay, where the objects have states and behavior. So for example here, a dog has states. A dog might have a breed, baka dia, color dia, nama dia, kan? As well as behavior dia, types of barking, types of eating, panjang ekor dia, for example. So an object is an instance of the class. So kalau macam base class here, we call it dog. Where dalam base class here we have property. Dalam property ni kita ada color, eye color, height, length, weight, methods. Methods is the operation lah, the things that ERD tak ada. Okay, dogs can sit, dog can run, dogs can lay down, dogs can shake hand, can shake. Dog can throw balls, for example. Then from this base class, you create instances. This instance, which an object to this class, a dog called Bobby, where attributes or the properties that the Bobby has, a yellow color dia, eye color brown, the height in inches, and weight in pounds. So the methods, Bobby is the same. It's the same. So maybe, and then you can create another instances. Sebab kamu dah belajar OP, saya harap kamu faham fungsi instances for each class. So dekat sini contohnya blueprints, objects. Classes is the blueprints. Object is the instances of the class. So you're in UML notation, UML class notation, a class represent a concept which encapsulate maksudnya benda ni kena ada, the name, the attributes and the behavior. Attributes and the behavior must come together and achieve lah. Kena identify. So each attribute has a type. So each operation has a signature. So the class name is not the only mandatory information. Encapsulate tu maksudnya ketiga-tiga bahagian tu container tu mesti kena ada. Yeah. So the class name is not the only mandatory information that they must have. They also must have attribute and its operation. Okay. So class without signature, class with signature. So usually conceptual types like this. Yeah. So untuk design kelas ISP550 ni, you can go as detail as this, tapi paling asas you must have this, okay, for basic. Okay, class with signature, you dah identify the type, okay, the types of each attribute. Okay. And get length ni kalau dalam coding you nak pakai apa dia punya data type. Okay. And then you dah start dah dia punya parameter dia. So ni dalam very detail lah implementation specification. Okay. So basically a name, ini example of a class. Atas sekali class name and then class attributes. Yeah. Attributes are shown in the second partition. The attribute type is shown after colon. Okay. Attributes map onto members variables, data members in quotes. And the bawah ni operations or the methods. There are services the class provides. The return types of a method is shown after the colon at the end of the method signature. The return types of method parameters are shown after the colon following the parameter name. Operation map onto class methods in code. Okay. So you dah nampak perspektif tadi, contoh classes. Okay. Now kita belajar tentang relationship pula. Okay. So relationship shows the interactions lah, between one class to another. Okay. A class may be involved in one or more relationship with other class. A relationship can be one of the following types. Association, which is a common types of relationship. Inheritance, when they have specific inheritance type. Realization, tengok dia punya types dari segi line dan kepala arrow dia. Realization dia putus-putus. Dependency, putus-putus dan simple arrow. Aggregation and composition. So biasanya kita kena tahu lah association, inheritance, aggregation, composition at least. Kena faham. So associations are relationships between classes in UML class diagram. Yang ini sama macam ERD. Any association types, dia mesti kena ada cardinality. Ingat cardinality? Constraint between association from one class to another class, kita mesti identify dia. Sebab apa? We need to set constraint to it. Yeah. So exactly one, types dia, exactly one, 0 or 1, 0 or more, 1 or more, or ordered. Alright. Jadi lazim. Now this is special about OOP. Inheritance, or another name to refer to it is generalization. Saya percaya kamu dah belajar OOP, ISP550. So I would say that you already have a basic understanding on inheritance. Inheritance ni when you have satu superclass dan kamu ada subclass. Dia bila ada dia berlaku bila ada shared common attributes, that the subclass instances shared dengan superclass. Ingat term-term ni. So generalization is a taxonomic relationship between a more general classifier and more specific classifier. Okay, it's each instances of the specific classifier is also an indirect instances of the general classifier. Thus, the specific classifier inherits the features of the more general classifier. So dia ada terms is a relationship. Okay. An abstract class name is shown in italic. So dekat sini kita ada contoh, kat sini ada 3 subclass of shape. Class shape kita ada polygon, ellipse and spline. So example hierarchical inheritance kat sini, polygon, ellipse and spline are derived from shape. The relationship is displayed as a solid line with an hello arrowhead point of this. Another, you can use this types, tapi yang ini kepala dia kena betul. Sebab daripada sini saya tahu ia adalah generalization type, ataupun kamu boleh menggunakan arrow simple macam ni. Okay, either one. Okay. Tapi konsisten lah, kalau guna style satu, guna style satu. Realization is a relationship between the blueprint class and the object containing its perspective implementation level details. This object is said to realize the blueprint class. In other words, you can understand this has a relationship between the interface and the implementing class. For example, the owner of the interface might specify method for acquiring property and disposing of property. The person and corporation here, classes, need to implement this method possibly in a different way. So the way it view things yang kita nak set pada different types of class of person and corporation here. Dependency is an object of one class might use an object of another class in the code of a method. If the object is not stored in any field, then this model is a dependency relationship. Okay. A special type of association exists between two classes if changes to the definitions of one may cause changes in another. So that is dependence. Class 1 depends on class 2. Yang mana a person depends on what books that they borrow. Ataupun what books that they read. That also boleh capture dalam UML. Aggregation is a part of relationship. Class 2 is part of class 1. Many instances denoted by the asterisk of class 2 can be associated with class 1. Objects of class 1 and class 2 have separate lifetimes. Example here, the relationship is displayed as a solid line, with an unfilled diamond at the end of association, which is connected through a class that represents the aggregate. Aggregate putih dia punya ni, composition hitam it shows some sort of a strong relationship compared to aggregation. Aggregation is considered a weak relationship. Okay, whereby kat sini class 2 cannot stand on itself. Kalau sekiranya class 1 dah tak ada. So the relationship is displayed as a solid line with a filled diamond at the end of the association, which is connected to the class that represent the whole or composite. Okay. Ini example of a class diagram with ini basic, customer to order, association, basic association, order to order detail, dia adalah composite. Why? Order detail only exists bila you generate order. Betul And then items is, yang ni apa tadi? Saya lupa. Kejap saya lupa. Dependency. Dependency. Alright. Maksudnya order details depends on which item that you buy. You nak simpan dalam table. Okay. For order and payment, association dia biasa. It's an association, it's a common type association. But payment dia ada three types of three types of subclass. Either you can pay by cash, check or credit. Right? So that is class and then of course dalam class diagram sama macam ERD, dia ada cardinality, that shows the multiplicity, the frequency that you can allow the process to happen or the methods to happen. Kecuali dalam generalization ni dia tak ada multiplicity lah for cardinality. The constraint that you set for each of the classes. Alright, setakat ni itu saja untuk class diagram. Ada soalan ke before we end the session? It's already 9:47. Kita dah ada dua sesi hari ini untuk tengok UML dan use case diagram dan class diagram. Sebab dua benda ni memang kamu kena mahir lah. Sebab industri pun memang pakai. Soalan? Makin sikit pula dah join yang second second Google ni second GM ni. Alright. Ada soalan tak? Kalau tak ada, saya end the session dan nanti saya akan sharekan slide ini, rakaman ini dalam YouTube dan saya akan bagi link juga ya. Untuk slide UML diagram ni saya tak ada ubah apa-apa dan untuk tutorial kita pada hari Khamis ni saya hanya akan bagi instruction untuk project implementation. Boleh ya, kita tak ada tutorial lah, saya cuma bagi apa yang saya expect untuk project implementation dan kalau ada nak soal berkaitan dengan project implementation and development boleh tanya masa hari Khamis tutorial nanti. Before we end the session, saya akan stop the recording tapi saya akan continue with sedikit lagi stop share, not stop share. Saya akan stop the recording. Cuma saya nak tunjuk sikit